Okay, so we may as well get started. So, yeah, algebraic proofs, they come up somewhat frequently, maybe every other exam series or so. And also the product rule for counting can come up a decent amount. So what I was thinking of doing is we'll just go through a bunch of the different proofs they can give you. You guys are going to catch on pretty quickly because it's a very similar method each time, just for the different types of proofs. Product rule for counting, again, there's a few different scenarios. I'm going to explain it to you and then just tell you a way on how to kind of remember it as well. But it can help to know exactly how it's done so you can apply it to different scenarios and things like that. And then at the end, if we get time, you can actually use it to work out, you know, what the likelihood of winning the lottery is, which I think is somewhat interesting. Maybe you guys will be interested in that as well if we have time. But yeah, I think we can just get started. You may have done these before, but some schools don't actually do this topic because it doesn't come up that frequently and they don't have enough time. So I just want to make sure that you guys have some exposure to it. So it says, prove algebraically that the sum of any two consecutive integers is always an odd number. So yeah, Evie, you've got the right idea. So the first things first is consecutive means they have to be one after another. So for example, if I write out, right, these two are consecutive, these two are consecutive, these two are consecutive. It just means they're next to each other in a list. So if I just say an integer is n, right, then the next integer, which is consecutive, would just be n plus 1, which hopefully should make sense. And that would just be 2n plus 1, right, which is exactly what Evie said. But hopefully it's clear why this would be an odd number. If you take any number and times it by 2, which is the first part of this calculation, 2n, you always get an even number. And then when you add a 1, if you add 1 to any even number, you always get an odd number. So that's why it's an odd number, okay? Because again, this is always even, and even number plus 1 is always going to be odd. So again, starting with something relatively soft, but there are some pretty tricky, well, somewhat tricky ones. Okay. Again, I'm just going to keep going, but as soon as you see something you don't understand, then let me know. But again, there is a chat delay, so keep that in mind. Prove algebraically that the sum of any three consecutive even integers is always a multiple of 6. So an even number can just be written as 2 times n, because 2 times any number is an even number. Now the next even number, if I write out the even numbers here, these are the consecutive even numbers, right? 2 and 4 consecutive, 4 and 6, 6 and 8. So what you do is you jump up by 2 each time. So the next one would be 2n plus 2. And the last one will be 2n plus another 2, so plus 4. Then all you need to do is add all of these together. So 2n plus 2n plus 2. I will say that, for any of you that want to do A-level maths, proofs comes back in full force, a bit more beefy than it is here, but it will kind of come back again. Good question, Evie. So you can't. And the reason for that is n is normally just defined as any integer. Okay? So if I just say n and it has to be even, that wouldn't work. And in fact, if you subbed it in, you'd find out it wouldn't work. It has to be 2n, because again, yeah, because you don't want to limit it. Generally speaking, n is just any integer at all. Okay? So 2n would be how you'd define it. And that's how a lot of these proofs work. But good question. So then if I gather the like terms, I have 2n plus 2n plus 2n, and that's 6n. And then I have 2 plus 4, which is 6. Now it's saying, show that it's always a multiple of 6. Now this is a very common part of the proof. So first of all, you have this, right? You need to show that it equals 2n plus 1, right? That's one thing, so prove it's an odd number. To prove something is a multiple of blank, all you have to do is show that you can divide it by that number, okay? And the way you do that is by factorizing it out. So, equals. I could write this as 6n plus 1, okay? And that is my proof at the end, because I can obviously divide this by 6 because I have a 6 out front. If I divided it by 6, it would just get rid of the number in front. But if this said multiple of 12 or 3, all you're doing is pulling out or factorizing out a 12 or 3. And now if it said prove it's an even number, then all you're doing is factorising out a 2, because even numbers are multiples of 2. So far there's only 2 variations. You have prove it's odd, where you're going to have to make it equal 2n plus 1, or it's going to be a multiple of a certain number, or even, where you just pull out whatever that multiple is. So it could be a multiple of 3, 6, 12, whatever. And if it's an even number, you're just pulling out a 2, which hopefully should make sense. Are there any questions about that at all? Again, we've only done 2 examples, so if it doesn't make full sense right now, that's okay. Okay, good. Okay. So, perfect. So again, in this question, this thing here is different, but it says prove it's a multiple of 12. So all we're going to do is factorise out a 12 and we're done. That's it. So if I were to expand this, 3n plus 1 squared would give me 9n squared plus 6n plus 1. If I expanded that. Then we have minus, and if I expanded this bracket, I would get again 9n squared plus 6n plus 1. Hang on, I've made a mistake. That should be a minus n. Please? There we are. Minus 6n. Okay, now we expand the brackets one more time. So can you see that the 9n squared minus 9n squared goes away, the plus 1, the minus 1 goes away, so that equals 12n. So obviously that would be 12 times n, so it must be a multiple of 12. Right? It's 12 times a whole number, which is always going to be a multiple of 12, right? It could be 1, 2, 3, 4, etc. So again, it's the exact same thing as this. Okay. So there's a few other styles we're going to do, and there are some exam questions. Where'd you get minus 1 from? Ah, good question. So in this last step here, I have to expand this bracket. And as you can see, there's a minus in front of it. And since there's a minus in front of it, you need to put a minus in front of everything inside the bracket. So you do minus times 9n squared, so that's minus 9n squared. Minus times minus 6n would be plus 6n, and then minus 1 times plus 1, which is minus 1. If you'd like, it's just flipping all of the signs inside. Are your papers out yet? Again, only 1A at the moment. I know, it's kind of frustrating. My friend who needs to do the mark schemes, she was very busy recently, so she hasn't been able to write them up yet. But I'm hoping they'll be done relatively soon. If not, I can just write them out, but she has some very nice handwriting. Okay. Okay. Now here's a slightly different proof. So far again there's 2 types, right? Prove it's an odd number, so you want to make it 2n plus 1. Prove it's a multiple of a certain number, including an even number, and then that's that. The next type is you need to prove that something is a square number. Now I'm going to show you how you do this, but it's really not too bad. But it says prove algebraically that the sum of n plus 1 and n plus 1 is always a square number. So sum just means add. So I'm literally just doing n plus 1, add, if you want you can put it in brackets, n plus 1. So now I expand the brackets, right? N squared plus n plus 1. Right, so again, n times n is n squared, n times plus 1 is plus 1, plus n, sorry, is product multiplying. Product is multiplying, yeah. And then plus n plus 1. Cool. Now if I simplify this, I get n squared plus 2n plus 1. So what you need to do in this case, if you want to prove it's a square number, you're always going to be factorising what you have. Okay, so whatever it is, you're going to factorise it. Because to show that something's a square number, you need to show that you can square root it. Okay, now I can't really show that I can square root this. That's pretty tricky, right? So instead I'm going to factorise it. So I'm looking for 2 numbers that times to 1 and add to 2. Well, 1 and 1 come to mind, right? So then I have n plus 1, n plus 1. And the way I write that is n plus 1 squared. If I can write something as a thing with a square, it means it must be a square number, right? 2 squared is a square number, it's 4. 3 squared is a square number. 4 squared it has to be a square number, right? Because I'm squaring it. So it has to be a square number after I'm done squaring it. I said the word square a lot, it kind of lost all meaning, but I hope that makes a bit of sense. If it doesn't, then please let me know. This is the other type that they can give you. So there's 3 types so far. Prove it's odd, prove it's a multiple, and prove it's square. And by the way, when I say prove it's multiple, that counts prove it's an even number, because even numbers are just multiples of 2. Okay, so the method is exactly the same. So 3 ways so far. Okay, I think that's okay. Hope that is anyway. Okay, perfect. So again, we have, prove that this is a multiple of 12 for all positive integer values. I'm going to start picking up the pace ever so slightly so we can get onto a lot of stuff, because I've got a ton of questions, including exam questions and things like that. So again, you're going to expand both of these brackets. So 2n times 2n will give me 4n squared, plus, so 6n plus 6n will be 12n, plus 9. So I've done this very quickly, so please let me know if you aren't sure. 2n plus 2n will give me 4n squared. Then we have minus 6n, so we have minus 12n. Then we have plus 9. Again, I'm going through that slightly quickly, just so we can get through a bit more, but please let me know if it's confusing. And then again, we want to expand the brackets one last time, so 4n squared plus 12n plus 9. I would recommend doing this intermediate step, because it's very easy to mix up the signs in an exam. Okay, so again, minus 4n squared. I literally just times it out. So minus 1 times 4n will give me minus 4n squared. Minus times minus 12n would give me plus 12n. Minus 1 times plus 9 will give me minus 9. So I'd literally recommend doing that so you don't make a mistake in the exam. The plus 9 and the minus 9 cancel, of course. The plus 4n squared cancels with the minus 4n squared, of course. So we're left with 12n plus 12n, which is 24n. And if you remember, we need to prove it's a multiple of 12. So we need to show we can factorize out 12. So we have 12 times 2n, which means it is a multiple of 12. Perfect. Just for your information, so again, if you're doing A-levels, this comes back. But the reason why we do it with algebra is because, if you think about it, if we tried to prove this by subbing in numbers, we would be here until the end of time, because there's an infinite number of integers. So if you do it algebraically, it proves it for every single number in existence that's an integer. That's why it's very useful, because otherwise you have to just do like a billion different cases, or an infinite number of cases. That's pretty good. Very good. Okay. Okay. So again, always a square number, so I'll do this one because this is like the second square number one we've had. So again, it says sum, which means add, and as Lila asked earlier, product would mean you times them, and they can ask for product. So that's a really good question. So we have n plus 2, n plus 1, plus n plus 2 in brackets. So let's expand the brackets. N times n is n squared, plus 2n plus n would give me plus 3n, and then plus 2, plus n, plus 2, so n squared, plus 4n, plus 4. So once again we're looking for, so again we need to factorize it to show that it's a square number, and it needs to times to 4 and add to 4, so the only numbers that would work are 2 and 2. So we have n plus 2, n plus 2. Again, I am doing it in like a slightly longer way, in the sense where I'm writing everything out in full, but that's just to make sure everyone's fully on board. You can go from this line to this end line here, that's fine. And yeah, you get n plus 2 squared. Because I'm squaring it, it means it must be a square number. Again, once it gets too easy, just let me know, and we can go ahead. This one will be good to do as well. Too easy so far? Okay. It'll get slightly more challenging. Slightly more. This one is very similar to the consecutive even numbers one. So if you want to ever write an odd number, you would write it like this, 2n plus 1. So again, I'm not sure how many people have just recently joined, but just as a reminder, if you times any number by 2, it becomes even, if it's an integer. If you add 1, it has to become odd. So if you ever want to write an odd number, you always write 2n plus 1. Now to get between all of the odd numbers, to get to the next one, you're always adding 2, right? So for the next consecutive odd number, it would be 2n plus 3, and then 2n plus 5. Because again, we're just adding 2 each time to get to the next one. It wouldn't be 2n plus 2 because that would be an even number. Then all we're doing is we're adding all of those up. So 2n plus 1 plus 2n plus 3 plus 2n plus 5. So we get 2 plus 2 plus 2 is 6n. 1 plus 3 is 4, plus 5 is 9. Cool. And prove it's a multiple of 3, which means we factorize out a 3. So again, 3, and we get 2n plus 3, which means it must be a multiple of 3. I hope that's okay so far. There are some other types which might get a bit tricky. A linear sequence instead of consecutives. I suppose there's no reason why not, but I've never seen it. So if you mean like they could give you, prove that n plus 2 plus n plus 5 plus n plus 10 or something, maybe, but I've never seen it. The consecutive even numbers will be the same thing as the odd numbers, except you're just going to be adding 2n, 2n plus 2, and 2n plus 4. We did do it a bit earlier, but again, all you're doing is you're doing 2n plus 2n plus 2 plus 2n plus 4, and then you'd factorize out a 6. Okay, so, I need to do that. I think that should be okay, right? This can get, this is a bit more interesting, these next two. So if you look here, prove algebraically that the sum of the squares of any two even positive integers is always a multiple of 4. So if you notice, it doesn't say consecutive, right? It just says any two even integers, okay? So my first integer would just be 2n, because if I want to write an integer, I can just write 2n. Now, if you want another integer, which could be any number, you can just use another letter, okay? So we might use 2m. But technically speaking, you can use any letter you like. You could say 2q, 2z, 2N if you really want to be an agent of chaos. Anything you like. But is it okay if I just use 2n and 2m because they're next to each other? And you see how that shows that they're two different numbers. But they're not necessarily next to each other. They could be any number. Okay. It's getting slightly more interesting. Perfect. Okay, and then it says, prove that the sum of the squares. So with this wording, it can be a bit tricky sometimes, but when you take the sum of the squares, you're squaring first, then adding. Okay? So it's not this. It's not that. Instead, it's 2n squared plus 2m squared. Like you're doing Pythagoras. The sum of the squares. It's not you sum them then square them. You square them then sum them. And it will give you two completely different answers. So if I expand that, I get 4n squared plus 4m squared. And it says, prove that it's always a multiple of 4. Well, again, I can just factorize out a 4, and I get n squared plus m squared. So what I'm hoping is that this isn't tricky mathematically, but what is tricky is that you haven't seen these situations before. But once I give you like the hint, like for example choosing n and m for example, you might not think about that. But once you have it, I think it becomes somewhat easy after that, right? But it's the thinking about the beginning that's the difficult bit. Thinking about the beginning. Yeah, okay, that makes sense. That can be slightly tricky. But after that, I think it's... Like, this maths isn't too bad. It's just actually thinking about it. So I'm hoping to just arm you with the knowledge of which one to choose. And then from there, you'll be fine. So what if it's odd? So it's literally the same question, but it's odd. Well, again, if I choose one odd integer, it's 2n plus 1. If I want to choose a completely different one, and again, they aren't necessarily next to each other, you just do 2m plus 1. So would you guys want me to go through this, or is this okay? Again, you're squaring them and then adding them, and then if it's always even, you can literally write this as multiple of 2. It's okay? Perfect. Good to hear. Okay. Prove that the sum of the squares of any two consecutive integers. I think that would be okay. So in this case, you would have n and m plus 1. Square them, add them, and then you want to show at the end that it is 2n plus 1. Yeah? Actually, this one, it's not strictly speaking 2n plus 1. Okay? So I'm going to go through this one. So again, sum of the squares, so all we're doing is doing n squared plus m plus 1 squared. It's slightly different, that's why I want to go through it, but I'll go through it relatively quickly. N squared plus 2n plus 1. So then if I add this up, I get 2n squared plus 2n plus 1. So if you look, it doesn't look like 2n plus 1, right? So it's not going to be just 2n plus 1. So what you have to do instead is this beginning bit here, I can show you that it's always even, right? And if I show that this beginning bit's always even, if I add 1 to an even number, it becomes odd. The way I show this is by writing 2 n squared plus n plus 1. This bit here is always even because it's times by 2. And if I add 1 to an odd number, if I add 1 to an even number, it always becomes odd. And then you could just write like even plus 1 equals odd. That's why it's 3 marks. There's like a slight bonus bit, if you like. Is that okay? The next one's pretty good as well, actually. Maybe I should do the next one too. Okay. So again, it's a bit of a trick, but similar thing, right? Yeah. This next one, I'll do this next one, and then... And then I'll see, and then I'll just ask you how to, you guys if you're okay. I'll do this next one, then I'll leave it to you guys to decide which ones we do. So again, anyone that's watching, you can like basically vote. We'll run it like a democracy after this one. For now, it's a dictatorship. So prove that the sum of the squares of two consecutive odd numbers is always 2 more than a multiple of 8. That sounds really complicated, right? But let's have a look. Squares, we've got sum, consecutive odd numbers, and then 2 more than a multiple of 8. If you break it down, it's not too bad, right? So the first bit we're going to look at is the consecutive odd numbers. So again, we have 2n plus 1 for our first odd number, and then 2n plus 3, because again we add 2 to get the next odd number, right? Okay, so we've done this bit. Good. Now we have to sum and square them. So we're going to do the sum and square bit now. So that's going to be 2n plus 1 squared plus 2n plus 3 squared. Also, I would like to point out that just doing this bit here, like these beginning bits, can get you marks. So if you're ever unsure of how to do a proof, just do this first bit. And generally speaking, you can get a couple of marks. Maybe 1, maybe 2. But what you will get is more than 0. Okay? Okay, now let's work this out. So we're going to square and expand it. So again, I'm going to do the expansion a bit quickly. But if you're unsure, please let me know. I really don't mind. And that'll be plus 4n squared plus 12n plus 9. Then we're going to gather the like terms. So we have 4n squared and 4n squared, which gives me 8n squared. So I'm going to cross those out. Then we have 4n and 12n, so that's 16n. And then we have plus 10. Okay. This is a bit interesting, but the trick here is it says it's always 2 more than a multiple of 8. So what I want is I want 8 brackets with stuff in it plus 2. That's my ideal situation, right? Because again, 2 more than a multiple of 8, I'd have 8 times some stuff plus 2. So what if I just wrote plus 10 as 8 plus 2? I get my plus 2 and I can factorise out the 8. So that's exactly what I'm going to do. Spotting that, I didn't, oh God, words are hard. It didn't take me that long to spot it, but again, I'm used to these tricks that they play on you. But you have to just be open to this. Remember that when they say, exactly, it's really sneaky. When they say this, prove that the sum of 2 is this, it's definitely true. In A level, you will prove a statement true or false. With GCSE, everything they say is true in the context of proofs. So I know that it has to be 2 more than a multiple of 8. So then thinking, and I did this in my head, but again, I've done proofs for years longer than you have, and I did A-level proofs and university proofs and stuff, so take it with a grain of salt. But this is kind of what my thinking was. Okay, so it does test your imagination quite a lot. And I don't know how imaginative you guys are. I'm not imaginative at all. But I have the benefit of like 5 years experience on top of you guys. Probably more than 5 actually. Actually I think it's closer to 10. Which is depressing. But yeah. Hopefully that makes a bit more sense. Bit sneaky, but that's why I wanted to show you this one, because it is sneaky. Okay. We're making good time. We've done 12 questions in 27 minutes. It's 1 every 2 minutes. Not bad. This one here, again, it's a bit longer, but what I'll do is, I might not necessarily, again, you guys can decide if we go through it, but it says the difference, which means you're going to subtract, right? Between the squares of 2 consecutive integers, so all you're doing is you're taking n and n plus 1 is equal to the sum of those integers. So what you do is you do n plus 1, which is 2n plus 1, and then you'd square these and subtract them and show it's the same thing. That's it. Again, I don't mind going through it, but honestly, if you just square and subtract these, you will find that it equals this. There's no tricks, there's no tomfoolery, no mischief. It's pretty much what it says on the tin. And again, you would do n plus 1 squared minus n, right? Because you take the bigger thing minus the smaller thing. Because when you say difference, you don't care about negatives. What you're just doing is finding what the difference is between them. So you do the bigger minus the smaller. Is that all okay? God. Okay. It seems like Evie's the only one that voted, so she wins that democratic election for that one. All good, yeah, perfect. Okay, Lila did as well. This one, again, there's no tricks. There's no mischief here. Okay? It's a rigged election, exactly. That was that Robert Mugabe guy, right? In Zimbabwe. Anyways. Prove algebraically that the sums of the squares of 2 consecutive even numbers is always 4 more than multiple of 8. It's not like the tricky one from before. You literally get 8n squared plus 8n plus 4. You just factorise the 8n squared and the 8n to 8 to that. There's no trickery here. And they're worth 3 marks, not bad. I don't want to assume that's okay. And now we have the exam questions. Disappointing 3 marks. 3 marks is 3 marks, but the reason being is because it doesn't come up that often. They don't expect kids to have, I say kids, students to have revised it and schools to have covered it. But the thing is, that's an easy 3 marks, right? Like, you know, that's a steal in my opinion. It's quite good in that sense. So let's go on to the exam questions. 4 marks. So prove that, and they give you a fairly long expression, is a square number. So what a lot of students, so I actually went through this today with some kids at school, some students, I keep calling them kids, not kids, okay, at school today, and they saw this and they panicked and they said, oh, right, that was the literal reaction was, oh. But the thing is, it's longer, but it's worth 4 marks, it's not bad. If we expand this in steps, it won't be too bad, I promise. So we have 35, expand the bracket, so 3x times 3x is 9x squared. 3x plus 3x will give me 6x, plus 1. Okay, so I've done these 2 bits. And then you have minus 2x times 4x, which will give me minus 8x squared. Then we have minus 2x times minus 3, which gives you plus 6x. So again, we go through the same process. 9x squared minus 8x squared gives me x squared. So I'm going to cross that off now. 6x plus 6x is 12x. Cross that off. And lastly, 35 plus 1 is 36. Now, okay, it times to 36 and adds to 12. So if you can't spot this immediately, keep in mind, we can use our brains, and okay, that sounds really sarcastic, I don't mean it sarcastically, but we know it's going to be a square number. 36 is a square number, so I'm going to start with, what about 6 and 6? Would that work? It does. 6 and 6 is 12. Yeah, perfect. So if you can't spot it immediately, you can use it as a bit of a hint, right? Use the question to defeat the question. And that'd be x plus 6 squared. That's 4 marks. You get a mark for expanding, a mark for simplifying, and you get a mark here and a mark here. Done. 4 marks. And you guys could probably do that in about a minute. I went pretty slowly because obviously I'm trying to teach you guys it. Bad. Cool. 30 seconds, yeah. 25 on a good day. The next question I found, it was actually somewhat interesting. I say interesting. You know, it's GCSE maths, not exactly interesting. But check this out. They give you an expression for a different type of number. Technically speaking, you are meant to be able to recognize triangular numbers, but this is the expression for the consecutive triangular numbers. Okay? And it says, prove that the sum of 2 consecutive triangular numbers is always a square number. So again, slightly more interesting. Slightly. So what we need to do is add these. So let's do that. n plus 1 over 2 plus m plus 1 m plus 2 over 2. Now, it's a fraction, so I can just add these straight away. But I could also expand first. It's kind of up to you which way you want to do it. I'd rather combine the fractions, I think. I'm not 100% sure what I'd want to do, actually. Oh. Perfect straight line. And now we expand. N times n is n squared. N times 1 is n. I don't know why it took me a second to think of that. N times n is n squared again. So again, I'm doing the second set of brackets now, by the way. And then you have n times 2, which is 2n, then n times 1, which is 1n, so that would be 3n overall. And then 1 times 2, which is 2 over 2. Gather all the like terms. N squared plus n squared is 2n squared. So let's cross those off. N plus 3n is 4n. And plus 2 on the end over 2. And it's our lucky day. The 2 actually cancels with everything in the top. So what we can do is divide everything by 2. So we're left with n squared plus 2n plus 1. And we're trying to prove it's a square number. Now you might remember from one of the earlier questions, this is just n plus 1 squared. But if you're not sure, times to 1 adds to 2. So that would be 1 and 1. So you have n plus 1, n plus 1. I'm very well, thank you. How are you, AMC? So yeah, that proves it's a square number. So again, 4 marks. So they try and throw you off by giving you a different situation, right? You've never seen the expression for consecutive triangular numbers, but I didn't really care about it, right? I don't care it's triangular numbers. They could have called it whatever the hell they wanted to and still get the same result. Okay. So this here would be, do you remember how I said 10% of your marks are unseen, where they throw something new at you? This is an unseen part, right? So that kind of actually makes the rest of the paper easier, if you think about it. But again, they could give you some other type of number. They could give you, I don't know, cylindrical numbers or something, and give you a new definition, but it's the same process. I think that's okay. So, oh, well done. Thank you for saying you enjoy my videos. Yeah, best of luck on your channel too. Okay, so that's it for proofs. I think that's a pretty solid foundation. The next thing we want to go through is called the product rule for counting. Sounds a bit fancy, but all it's about is finding the total number of combinations, right? So let's say if I go to a restaurant, there's 10 starters and there's 10 main courses, or sorry, 10 starters and 9 main courses. How many total combinations are there? How do I work that out? That's all it is. Now, it's going to start off easy, but then there gets to be some funky business, okay? So, this is kind of an example of a fairly basic question, but I'll use it as an explanation of like how this whole thing works. So 12 boys and 15 girls in a class. 1 boy and 1 girl will be selected to represent the class on the student council. Work out the total number of ways of choosing a boy and a girl. Now again, you might instinctively know the answer, but let's go through the boys and the girls. If we pick boy number 1, how many girls could he be matched with? Well, there's 15 girls he could be matched with, right? Okay, what about boy number 2? He also has 15 possible girls to be matched with. Boy number 3 also has 15 number of girls, and all the way up to boy number 12, who will still have 15 girls he can be matched up with. So in other words, there are 12 times 15 combinations. Okay? So I'm hoping that, makes sense, right? Which is 180 possible combinations. Yeah? So again, this might start off easy. I fully accept that. Okay? But I need to do it this way to make sure you guys understand a bit later on, because they can introduce some weird stuff. Okay, there are 17 boys and 14 girls. 1 boy and 1 girl will be selected. Well, okay, boy number 1 matched with 14 girls. Boy number 2 matched with 14 girls, and so on. So once again, 17 times 14. So hopefully you can actually see why they call it the product rule for counting, right? Because all we're doing is we're taking the product, the multiplying of 2 numbers, and that should be 238. By the way, a lot of these questions are actually calculator, so don't worry too much about working out, but again, good old-fashioned column method. The next type of question they could give you is something like this. There are 14 boys and X number of girls in a choir. 1 boy and 1 girl will be selected. Taylor says there are 152 ways of choosing a boy and a girl. Could Taylor be right? So what they're basically saying is that 14x equals 152. Okay, so that means x should be 152 over 14, which, again, you'd have to use a calculator for this because hopefully you can see that 152 doesn't go into 14. 10.857. So Taylor isn't right because it's not an integer, right? We can't say there are 10.857 girls in a choir, right? I mean, how could you have 0.857 of a person, right? Doesn't really work. So that's another way they could kind of throw a curveball. So far I'm assuming this is fairly easy. So if I show you the next question, we all okay with that? And what about the next one after that, if there's 3 combinations? Does anyone want me to go through any one of those 2 questions, yeah? So that's fine. Lila, are you okay with that? AMT? Anyone else? Again? So Lila, do you want me to go through one? Oh, no, you're okay. Okay, cool. You're right, I did say, do you want me to... Wait, Evie, you're okay, right? I realised I asked you 2 different questions. I said, do you want me to go through it? And then I said, are you okay? So if you answered yes, yeah, okay. Cool. And again here, it's the same, as this previous question up here, right? You would do 5 times 6 times x equals 130. See if x is a whole number. Done. Okay. Again, perfectly fine. Fine. Meal deal, classic. This is fine too. This is fine too. Same thing. Now here's where things get slightly more interesting. I mean, very slightly. You can have different situations like this. So there are 52 cards in a deck. Peter's going to give 1 card to Casper, 1 to Kelly. How many different ways are there of doing this? So we give 1 to Casper first, right? So he has 52 possible cards he can get. Now Kelly only has 51 cards she could get, because she obviously can't get the card that Casper has, right? So in this case, it would be 52 times 51. Everyone okay with that? Should be 2,652. I promise you. Why 51? Okay, good. So think about it, right? So if let's say you and I are playing cards, right? Or maybe you and Lila are playing cards. If I give 1 card each to you, right? Once I give you a card, there are 52 cards you could get, because there are 52 cards in the deck. But once I've given you one, there are only 51 cards left in the deck. So the options that Lila has is only one of 51 cards instead of 52. Because one of the cards is taken by Casper. See, it gets a little more spicy, Like I said, we can actually work out the probability of winning the lottery if you guys like a bit later on. No. So yeah, in this case, it's literally in a deck, so it'd be 1. It's very careful with the wording. So yeah, it is a bit tricky. That's why I wanted to go through a couple of these. So let's do 11, right? So there are 52 cards in the deck, same as normal, but Angel's going to give 1 to Ben, Chris, and Dylan. Well, it's going to be very similar to what we just did. Right? Ben has 52 possible cards to get, but then he has 1 card, so now there's only 51 for Chris. And then again, 1 lower will be 50. Here. Yeah, university maths is a whole nother level. Stop trying to remember the rules for sequences and series. Or like summations and things like that, or geometric arithmetic. Pretty tricky. Yeah, Evie, Lila, is that okay? So once again, we're going to times that. Again, if any of the numbers don't make sense, please let me know. Cool. And then I'm just going to do answer times 50 because I really don't want to work that out. It's 132,600. I mean, that's how many combinations there could be. That's kind of crazy if you think about it, right? Like, if I just give us 3 1 card each from a deck, there's 132,600 combinations that it could be. I guess that's why poker is so exciting for some people. Yeah, that's pretty interesting. Convergence and divergences from A level. Yeah, that's quite cool. It's further math stuff that you're doing. Okay. And here is where it gets fun. Okay. 52 cards in a deck. Tom is going to give 2 cards to Jay. How many different pairs of cards could Jay get? So I'm going to call this J1 for the first card Jay gets. I'm going to call this J2 for the second card. Oh, crying out loud, that was horrible. For the second card Jay gets, right? Cool. So for the first card, he's going to get, there's one of 52 options. And the second, there's 51 options, right? So you could do 52 times by 51. Right? Which again, we've already done before. So you might be wondering why I'm finding this so interesting. That's 2652. It says how many different pairs. The problem with this... So the problem with this is this actually double counts. So what I mean by that is, let's take some examples. How well do you... Actually, okay. I'm not going to use the fancy suits or anything, but let's say Jay gets a 2 first and a 3 second, right? That's fine. When we do 52 times 51, that actually includes this as a unique combination. So a 2 and a 3 and a 3 and a 2 are considered two different combinations. Okay? The problem with that is if you want the number of different pairs, so if they ever use the word different or unique pairs, you need to half your answer. Okay? I'll give you a second to digest that while I read Freckles' comments. So, I'm in my first year, so it'll probably get worse, but stuff like component stuff, yeah, that's pretty... seems like uni in my country does further maths on UK level. To be honest, the first year of university, for me personally, we covered a lot of A-level stuff, and like further maths A-level. So, yeah, it's kind of like, it's not a recap, I would say, but it does kind of make sure you know the A-level stuff. It goes a bit further, but it is a lot of A-level. Finished A-levels in London and moved country for university, so that's interesting. Oh, cool. I've got C in my A-levels, so I'm not the brightest. Don't worry, but look, grades don't matter that much. Further math topics, you have things like complex numbers, various types of proof, slightly further integration and differentiation than what you would do in A-level, but yeah. So, okay, Evie, you see. Lila, how is that for you? Is that okay? Good. So again, the rule I'm going to give you is if they ever say different or unique or anything like that, or if they say, this is going to seem weird at the moment, but each team plays each other once, anything like that, you divide by 2 after you times it. Okay? Because they're looking to eliminate double counting, we call it, right? So getting a 2 and a 3 is the same as a 3 and a 2 if we eliminate that by halving it. So again, we have something here. We have 30 students in a class. 2 students are going to be selected to receive a prize. How many different pairs of students could be selected? Okay, so there's 30 students to begin with, but then after one person's been picked, there are only 29 students left, right? So we do 30 times 29, which is 870. But if you look, it says different pairs. Okay? So again, for us, we're just going to divide by 2 because that's the rule. Okay? But again, try and think logically, right? If we call the students A, B, C, D, etc., student A and student B being picked is the same as student B and student A being picked, so we're halving it. But either way, it's fine. I can go over a question if you have one, Evie, that's totally fine. There are a couple more that I would like to go through. Should I jump straight to the exam questions to make sure we have time? Freckle, got my final tomorrow, so hopefully I pass, but learning all these rules in a few hours is possible, let alone knowing which rule to use. I'd advise just doing practice questions instead of trying to memorise the rules. It will help you more, but best of luck with your final. So again, if you look here, there are 10 teams in a football league, 2 teams are chosen, work out the number of different matches. So again, you're doing 10 times 9, 90, divided by 2, 45. 2 marks. Okay, I think I want to start going through some exam questions. Okay, these are exam questions, but going through some of the recent exam questions that came out, which are a bit trickier. Look at this number of handshakes. How exciting, right? Okay, here we are. This one was a bit tricky. Actually, I'll leave it up, sorry. Liam's trying to remember a 3-digit code. He knows the rule that the first digit is a cube number, the second digit is a factor of 16. Thank you very much, Freckle, I appreciate that. And the third digit is an odd number. Liam tries at random a code that matches the rule, work out the probability. Okay, so if you remember, probability is the number of outcomes you want over the total number of outcomes. So there's one correct code, and we need to divide it by the total number of codes, right? Does that make sense? Because there's only one code that works, hopefully. And we need to work out the total number of combinations we have. Okay. So, the trick here is that it's a single digit. Okay? So the first digit is a cube number. Let's think of all the cube numbers that are single digits. Well, if I go through my cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So in other words, I only have 2 options, because after that, they start taking up 2 digits, which is not allowed. So I have 2 combinations, or 2 possibilities for the cube number. Okay. The second digit is a factor of 16. Okay, let's list all my factors of 16. Well, we have 1 and 16, we have 2 and 8, and we have 4 and itself. Right? There are no others. Good. So the ones that are single digits are 1, 2, 4, and 8. So there are 4 options here. Actually, it's probably awkward that I'm putting a thing here. It probably looks like a negative sign. I'll leave that. The third digit is an odd number. Well, let's list our odd numbers. We have 1, 3, 5, 7, 9, 11. So there's only this many odd numbers that are single digits. So that's 5. So the total number of combinations is 2, because there's 2 possibilities for this first. So I like to actually put it in a box sometimes, right? There are 2 possibilities for this first place, which can match with any 4 possibilities here, which can match with any 5 possibilities here. So in other words, you're going to times them all together. And in this case, we're not going to divide by 2, because the order matters. Okay? So, for example, getting a 1 and a 3 here is different from getting a 3 and a 1 here, right? If you think of a password. So 2 times 4 is 8, 8 times 5 should be 40. So the actual probability, which is where some people lost marks because they forgot to do it, would be 1 in 40. So you get 1 mark for this, and then you basically get 3 marks for the working out along here. But if you just get the right answer, you get all 4 marks, okay? But in terms of working out, you need to have like some of these steps put in. So Evie, Lila, is that okay? And others, by the way, if anyone else is here. I can see there's more people that are in here, but I guess they're shy, which is fine. Yeah, Lila? Perfect. Oh yeah, I was going to go through work out the probability for the lottery. I thought that might be interesting. Are you guys interested in it, or should we just jump straight to Evie's question? So again, let's do democracy. There's only 2 of you, so this is going to be interesting if you guys have differing opinions. But who would like to work out the probability of winning the lottery, just as like a test? Both of you don't mind. Okay, how about Evie? Let's do your question, because it might take a while. Who knows, right? So if you just want to like send the question or whatever. From your mock. Yeah, let's hope that I can get it right. Oh, there is another question. Huh. Democratic stream, yeah. I do have more questions here. There's a character, and there's... Yeah, okay. Bodies. Okay, so there's 8 bodies, 4 faces, and 5 hairstyles. What's the probability 2 characters are exactly the same? So if they're exactly the same, they would need to have the same body, the same face, and the same hair, right? Yeah, I think I know what they're going for here. So there's 160 combinations. I'm not even going to check it, I'm just going to assume you're right with that. So the probability of picking a character is 1 over 160, right? That's the probability that it's the... that's probably getting of one particular character, right? So in order to get the exact same character again, I'm assuming they make 2 unique characters, right? Not unique, sorry. They make 2 characters. What's the probability of them being the same? That's the question. Well, it will be times by 1 over 160 again. Wait, is that the question where it says what's the probability? So if they're making two characters, what's the probability they're the same? Because if so, yeah. So then all you do is do 1 over 160 squared, right? Or 1 over 160 times 1 over 160. 1 over 25,600? No, not add.